Now let's try some examples. So the directions on these for problems 65 through 68 say, decide whether each expression is or is not a polynomial. And if it is a polynomial, identify each term and the degree of each term. Then find the degree of the polynomial. So looking at this, 3a squared minus 4/5 a minus 2 plus 8 over a squared. Because we can rewrite this last term as 8 times a to the negative 2, if you think back about what we learned about exponents, this expression does not meet our definition for polynomial because our n in this case is not a positive integer. So number 65 is not a polynomial. So if it's not a polynomial, we can't find its degree. Looking at number 66, we've got k to the 4th, k to the 3rd, k squared, and here's our k to the 0. So all of those are exponents that are positive whole integers, and they are all being added together, adding a negative 8, adding a negative 11. So this one does fit the definition of polynomial. The individual terms we're going to be looking at are negative 7k to the 4th, 1.3 k to the 3rd, negative 8k squared, and negative 11. So to find the degree of each of the terms, this one has a degree of 4, this one a degree of 3, 2, and 0. So our term with the highest degree is the negative 7k to the 4th. So this is a polynomial of degree 4. Looking at number 67, we have an x to the 3rd y to the 3rd, another x to the 3rd y to the 2nd, an x to the 1st y to the 1st, and an x or y, or whatever letter you want to make it, to the 0. So that one also fits our definition for polynomial. Is a polynomial. And we're going to analyze each of the terms in this. X cubed y cubed is our first term. 12 x cubed y squared, negative xy, and 5. Then assessing the degree of the individual terms. Since this term has two variables in it, we're going to add their exponents together. So this term has a degree of 6. This one has a 3 and a 2 for a total of 5. Here, this is x to the 1, y to the 1. So this term has a degree of 2. And the 5 has a degree of 0. So our highest degree is the 6 right there. So this is a polynomial of degree 6. Then looking at our last example, we have 9w to the 5th. And if you remember back to the definition, it can be a sum of a finite number of terms. So in this case, we're only adding one term, or we only have a single term, meaning that not only is this one a polynomial, it's a specific type of polynomial, known as a monomial. So we're going to say that 9w to the 5th is a polynomial. Nomial, I spelled that wrong, there we go, polynomial, and we only have one term to evaluate, 9w to the 5th, and it has a degree of 5, and so our polynomial, since there's only one term to look at, is also going to be of degree 5. Having trouble spelling today.